This is the next problem, which is based on a very important property of the greatest integer. The property is greatest integer of x plus greatest integer of x plus 1 by n, greatest integer of x plus 2 by n, going up to the last term greatest integer of x plus n minus 1 by n. The sum of this is greatest integer of n into x. Now, you can see very similar to this, but there is a negative sign out here. Now, to get rid of this, we are using one more property, and that is greatest integer of x plus greatest integer of minus x is equal to minus 1 if x is not an integer. So, we will be calculating this with the help of this result. So, minus sign we won't be troubling us. So, clubbing these two results, we will reach to our result. So, the required result you can see, you can notice from here is, because there are 100 terms, so minus 1 you will get 100 times. So, it is minus 100 minus greatest integer of 1 by 3 plus greatest integer of 1 by 3 plus 1 by 100, and again it will go up to the 100 terms. And now we know the result of this, which is equal to the greatest integer of n into x. Here x is 1 by 3 and n is 100. So, from here we will get minus 100 minus 33. So, this comes out to be 133. So, the answer is the third one. Let us move to the next problem. So, this is the problem from calculus, a problem as hard as iron. For this JEE mains paper, you can see what is given here. M is a small, m is the minimum value of k for which the function is increasing in the interval 0 to 3, and capital M is the maximum value of f(x). We have to find out both small m and capital M. So, let us first concentrate on the first part, that is how to calculate the small m. Luckily for us, the interval is only positive and we need to differentiate f(x). So, first thing what I am doing here, I am taking this x inside the under root. So, it is k x cube minus x raised to the power 4. We need to differentiate this because the function is increasing. It is given in the interval 0 to 3. So, this is what we have. Now, this is the derivative. Now, this has to be positive. Since the function is increasing, this has to be positive. Denominator is positive, x square is positive. So, for this to be positive, 3k has to be greater than or equal to 4x. Now, x is lying in the interval 0 to 3. Now, we want to find out the minimum value of k for which this to happen in the entire interval 0 to 3. So, you can notice here the maximum value which the right hand side will take will be 12. When x is equal to 3, this will be 12, and for this to be greater than 12, k, the minimum value of k, which is small m, is to be equal to 4. If you put k is equal to 4, this will become 12. Now, for any value of x, this will be greater than this. So, we now know what exactly is the function for us. The function here is f(x) is equal to, this is 4x cube minus x raised to the power 4. Now, the next part, coming to the next part, there is a capital M. Capital M is the maximum value of the function in the same interval, that is 0 to 3. Now, this is easier. If you think of it, the function in this interval is entirely increasing. So, the maximum value you will get at 3. So, this is where you will get the maximum value. So, calculating capital M is very easy. So, the capital M, that is the maximum value, we will get at 3, and putting here 3, we will have 4 into 27 minus 81, and this is what we will get here. This is 3 root 3. So, the capital M is 3 root 3 and small m was 4. So, which is the correct option? Let us see here. Here we are, this one is the correct option. Let us move to the next problem. Here we are on to the next problem. It is again on 3D. The intersecting points of the plane and the line. The two planes are given to us, and this line is intersecting both these planes at P and Q, and we want to calculate the distance between P and Q. So, let us see the figure first. What is the figure we are having? So, this is the figure which is actually telling you about the entire problem. This is the first plane where the line is intersecting at P, and this is the second plane where the line is intersecting at Q. So, let us first take any point on the line, this line. If we equate this to lambda, then the point can be taken as 3 lambda plus 2 comma 2 lambda minus 1. You can notice from here, and it is minus lambda plus 1. So, this is a point which we have taken on the first plane. Now, if I am satisfying this point in the first plane, I will get the required value of lambda. So, satisfying in the first plane, we have twice 3 lambda plus 2 plus 3 2 lambda minus 1 minus lambda plus 1 plus 13 is equal to 0. Now, calculating, this is 6 lambda 12 plus 1, that is 13 lambda, and again this is 4 minus 3, that is 1, and minus 1 0. So, this is minus 13. So, lambda from here is equal to minus 1. Again we are taking one point on this in terms of mu. So, in terms of mu, if we can take another point and we will satisfy in the second plane. Now, the second plane here is, it is given this one. So, satisfying in terms of mu, we have here 3 into 3 mu plus 2, and again y. Now, what is y? It is 2 mu minus 1 and 4 z. So, 4 into minus mu plus 1, and that is equal to 16. It is given that is equal to 16. So, if you calculate mu from here, we will get the value of mu as 1. So, the value of lambda and mu are here for us. So, we have this point P. So, what is this point P? Lambda is equal to minus 1. So, this point will be minus 1, again putting lambda here, it is minus 3, and here this will give you 2, and again Q will be what? Mu is 1. So, putting mu 1 here, this will give you 5 and this will be 1 and this will be 0. So, the distance between these 2 points, that is P and Q, is equal to 6 square plus 4 square and that is 2 square. So, the value which will come out here is definitely the first one, that is 2 root 14.